Hey, welcome everyone. In this section, we're revisiting our good friend, the object. So there's a lot more to talk about with objects than what we've seen so far. Object literals are useful to store key value pairs, like we've been using them, to store arrays or numbers or strings, or even other objects. But there's much more to talk about with objects. Objects are very central to JavaScript, not only in the code we write, but also to the way JavaScript actually works behind the scenes. So this section I'm calling the secret life of objects. It's not really a secret in any way. It's very well-known stuff about objects. So we have a couple of goals here. We're going to cover a pretty diverse group of topics. They are all united by the thread of objects. They all have to do with objects in some way. We'll start by talking about new syntax enhancements, nice little shorthands or shortcuts for common things we do with objects. So we'll start there. Then we'll talk about methods. How do we add methods to objects? Or how do we create methods? We'll talk about prototypes. And this last point here is an important one. We'll talk about the keyword this, the bane of many JavaScript learners' existence, something that we'll spend a lot of time on in the rest of the course. We're not going to cover everything you need to know about it right now, but we'll get our first taste of this and see how it works. But we're going to start with a nice new syntax enhancement called shorthand properties. Shorthand properties are a new addition to JavaScript with ES 2015. They are not supported in Internet Explorer, but that shouldn't stop you from using them. It's a nice, easy way to create an object literal when you have variables. And you want to create a property where the key name is the name of your variable and the value is the value in the variable. So here I have a function called getStats, which is passed in an array. I need to just update this. I just moved this into a new function. Okay, there we go. So it passes in, we pass in an array, and we calculate the max of the array, the min, the sum of every element, and the average. So when I call it here, I'm passing in the reviews array, representing Yelp reviews or something similar. What I want it to do is return an object that contains all of these stats. So something like this, return max is set to max. The min property is set to the value of min. Sum is set to sum. And average is set to average. So this works, and this is how we had to do it until ES 2015 with the shorthand syntax came along. So if I run this right now and I take a look at stats, we do get an object back. And it's what you expect. We have the keys, sum, min, max, and average, and their values are set to the corresponding values from the variables. But with this shorthand syntax, what we can do is write it like this. Return, and then we simply write max, min, sum, and average. And this will create a key with the name of max, the value with the value of max. So we're taking variables that we have and using them to both set the key name and the corresponding value. If I refresh my page over here and I look at stats, we have the same exact output or the same return value. It's just shorter. We don't have to duplicate the key and the value. It's done for us automatically. So that's pretty much it for the shorthand syntax. Here's an example from early on in the course when we covered functions. One of the exercises was to build a getCard function, which returns an object, I'll just call it over here, containing a suit and a value. This would be representing a single playing card. And the way that I wrote it was I have a pick function that picks a random element from an array. And then I have my cards, the values, and then the suits. And I'm picking a value, saving it to a variable called value, picking a suit, saving it to a variable called suit, and then returning an object where we have value set to value, suit set to suit. So we could just improve this very quickly by just doing this instead. And if I save and run it one more time, it still works. All right, so a nice shortcut syntax. Just remember, it doesn't work in Internet Explorer, like almost everything else that's nice to use in JavaScript. Next up, we have another nice new syntax addition to objects called computed properties. So computed properties are just an improvement for the object literal syntax where we can add a property with a dynamic key. Right now, if we want to make an object with a dynamic key, for example, if I want an object where I have the key set to the value of role, which is host, and then the value for that key would be Jules Holland, the variable person. If I make my object const, let's call this jobs, or how about team? If I tried to do role and set that to person, we've seen this before early on, we'll just end up with the key of role. That's not what we want here. If I look at team, we have role set to Jules Holland. So person is evaluated. This is computed. We get the variable value, and that's stuck in the object, but role is turned into a string. It's not checked if it's a variable. It's not computed. So what we've done in the past, in order to make this work, if we want a dynamic value for the key, is to go back after we initialize the object, do square brackets, team of role equals person. And now if we look at team, we have host set to Jules Holland. And let's say I had one more, const role2 equals, how about director? I don't have the actual any person in mind, but we'll go with person2 equals James Cameron. Okay, and if I wanted to add this in as a pair, I would need to then do team of role2 equals person2. And now we have two properties with dynamic keys. And we have to use these square brackets as we've seen. If you tried to use the dot notation, you're just adding the key of role. But now with this new syntax for computed properties, we can do this all at once. We can define our object and then dynamically add in a key based off of some computed variable, an expression. The code will be evaluated first. We'll retrieve the variable value and use that as a key. And this is what it looks like. We use the same square brackets, but we wrap it around the key in our property definition in the object literal. So here, a user will be evaluated first. We get Jules, and that's set to admin. So if we try it over here, we would have role in those brackets set to person. And then I could do a second one, role2 set to person2. Let's take a look. There we go, the exact same object that we created up here, but now we're doing it all at once. All of our properties are in the object when we are defining it. We're not having to do it after the fact. We don't make an empty object and then add a property and a second property. We can just do it all at once. And that's kind of it for computed properties. You could also put in more complex expressions in here. For example, I could do 1 plus 6 plus 9 and set that equal to, how about 16? If I evaluate this, take a look, we have 16 set to 16. So this is going to be evaluated and then turned into a string, like all the keys we've seen, and then used as the key in the object. Here's one more example. Let's make a function that accepts an object and will return a copy of that object with a new property added in. So we'll call this function add property, or just add prop. It will accept an object and then a key and a value. And we want it to return a new object based off of this obj parameter with a key and a value pair added. So without this computed properties new syntax, we would do something like this. Make our copy of the object. I'll use spread obj, that's an easy way to make a copy. And then we would set copy of k equals v, and then return copy. And if I called this now, I'll use my team variable. We would do add prop of team. Let's add in a new property. We'll go with happy, and then the corresponding string will be a happy face. So we have a key and a value. We'll save this to a variable, const res. Let's look at result. Okay, so it worked. We ended up adding in happy as a key and a happy face, the string, as the value. This is not using computed properties, so we had to make the object, then we had to go ahead and update, add in a new property with the dynamic key and a value. If we instead wanted to rewrite this using computed properties, we could do it on one line. It would be an annoying one line, but we could do it on one line. I'll do an arrow function this time, so const add prop equals object key value, and then we'll return a new object that contains everything from obj. We're spreading it in, we're copying it, and using square brackets, compute the key and set it equal to the corresponding value. So this does fit on one line, but when I save in my editor, it decides to auto-format it to multiple lines. You could also use an implicit return to even shorten it more, but let's just make sure it works. Let's look at res. We get the same result. So that's one use for a computed property. When you are creating functions that either return objects or add things into objects, it's pretty common that you might want to add a dynamic key in. Now, just as a bonus here, we're done with the computed property stuff, but if we wanted to refactor this to be a one-line arrow function, or at least an implicit return arrow function, remember that when we return something implicitly, we don't need the return keyword, and we don't need the curly braces, so we could write it like this, and then just move it all into one line, except for the fact that JavaScript will get confused, because this looks like it's a function body. It looks like the curly braces are for a function. It doesn't know that we're trying to implicitly return an object. If we had something like 5 here, this would implicitly return 5. But when we have an object, it gets confused, so we do have to put parentheses around it. And I'm pretty sure it's going to auto-format to multiple lines anyway, but this is valid on one line. Okay, so that's computed properties. We used the exact same square bracket syntax that we've been using so far, but now we can use it directly inside the object definition. Next up, we have a really important topic in the world of objects, the idea that we can add functions to our objects. So we've seen that we can pass functions around, we can store them in variables, we can store them in arrays, we can pass them as arguments, we can return them from a function. We can also store them in objects. Now, why we would do this is a bigger topic that we will get to in pieces. The first, simplest reason we would do this is just to group functions together, to group functionality into some sort of cohesive unit. So here's an example. We have a math object that contains different functions that have to do with one another. So they're just grouped together, and it's just a nice organizational structure. So we call these methods when we add a function into an object, and we've been using the word method quite a bit when we do things like hello dot to uppercase. This is a method. And I mentioned this a couple times earlier. When we define a function on our own and we store it in a variable or just a function declaration, const add equals function x comma y, return x plus y. This right here is a function right there. But when we add it into an object and it lives on something and we call it with the dot notation, it is now a method. So these are built-in methods, but now we'll see how to add our own methods to objects. It's very straightforward. We already saw it on the slides. One question you might have is, I thought strings were not objects. I thought they were primitives. Aren't strings just a value? How do they have methods? That is something we'll get to in due time, so we're going to put that aside for now. But let's go ahead and define our object. We'll call it math. And I'll show you a couple different ways of adding functions in. So right now I have a function called add. I've used a function expression, saved it to the variable add. I could just do this. We saw this shorthand a couple videos ago. I now have an object called math. If I run my code over here, we look at math. The key is add, and the value is the function stored in add. So we have add as the key, and then you can see a function right here. If I want to call it, I need to use the dot notation, math.add, and then pass in 2 numbers. Now, because of the way I wrote this, I also could just call add and pass in values 2 and 5. I'm calling this function from here, versus if I do math.add, we're referencing the same function. It's the same variable or the same function in memory, but I'm accessing it in a different way. So it's pretty uncommon to define your function first and then add it into an object. Normally, you would do something like this, add colon function, and then add our arguments and put our function expression right here. So we'll just return x plus y. And if we want another property, if we want to do multiply, we can add another function. Add our arguments, x, or our parameters, x and y, and then we can return x times y. So now I have 2 properties, both of which are functions. I can still add in non-functions. I can add whatever I want to the object. I could do numbers, and that could be an array, 1, 2, 3, 4, 5. If I run this code, we look at math, we now have two functions in here, add, multiply, and numbers, which is an array, and I use the exact same syntax. Math.numbers is how I access that array. Math.add is how I access that function, but I'm not executing it until I add the parens, 5 and 6. Same thing with multiply. Multiply with no parens gives me a reference to the function. I'm getting the function, if that makes sense. I'm asking JavaScript, does this thing exist? Tell me about it. Now I'm saying, I know it exists, let's run it. And we get 42 when I multiply 6 and 7. So again, right now, this is just a nice way of grouping functions together, putting them in an object so that they're just in some sort of container. Rather than having a bunch of functions floating around, I now have this math object, which is the same idea as the existing math that we have in JavaScript. We've seen a couple of these methods, math.random. It's grouped inside of math. Instead of just having a floating random function we call, we have a math object that contains a bunch of different functions, or technically methods. So the terminology one more time. We have functions, which we've seen on our own, but when we add a function as a property in an object, we call it a method. So these are two methods. We'll soon see some additional things we can do inside of methods, some new constructs or new features. The keyword this will come up very soon in this section, which will make these methods more useful or more flexible. Right now, it's just purely a container. This object just stores functions and groups them together so that we can carry them around. It's like a purse for all of our belongings. Next, I'm going to show you a new syntax that makes it a little shorter to define methods, and then we'll go on and talk about the keyword this. So that's the basics of adding a method to an object. It's just a key value pair. The function is the value. Now, I didn't show this. You can use an arrow function. It's not that common for reasons you'll see in just a moment once we talk about the keyword this. But in addition, there is a nice new shorthand for adding a method to an object where we don't have to use the key value pair syntax where we have a key, colon, and then a function. Instead, we can write a function like this. So we give it a name, and this name will be used to create the key. We still need our commas to separate the properties, but now we don't have to do the key, colon, value. So this is a newer syntax. If we want to try it out, we'll make an object here called auth. And we'll have some dummy functions like login. And login will simply console.log logged you in, like that. All right, so nothing very extravagant, but we have a function in here, and it's actually a method. If we look at auth, this is what it turned into. We have login as the key, and then the function that corresponds to it as the value. So it uses this to create the key. And again, we do need commas if we have more than one property in here. So inside of auth, if I wanted to add username is TommyBoy, TommyBot, sure. We need a comma, and it still works. We now have two properties. To add another method in, same thing. I need my comma here, and then we can go with logout. And we'll console.log goodbye. Now we'll take a look at auth one more time, and we have three properties. If we leave that comma out, it's not happy with us. It doesn't know what to do. We are in an object. Even if we're using this nice shorthand, we still need to separate all properties by commas. And that's kind of it. It's a nice shorthand. It is new, so it's not something that you may see all the time in older tutorials, but it's here for a reason. We do this so often. We add properties to an object. This is just cleaner. We don't have to write this login, key, colon, and then a function expression. We don't have to clutter our code with the function keyword, or if we use an arrow function, we still would be cluttering this. I'll just show you that we can do an arrow function. We still are cluttering our code here with the login key, the colon, just additional. Here, it's a lot shorter. Okay, and that's it. Next, we've got a big one. We're going to talk about the keyword this, a really fundamental thing in JavaScript that helps us write much more useful methods in our objects. Next up, we'll see one of the keys to writing useful methods in our objects. It's called the keyword this. Now the keyword this is also pretty useful. It comes up a lot once we get to DOM manipulation, which is right around the corner. When we do things like add events, click events, and keyboard events, we'll sometimes reference the keyword this. And you've probably come across it if you've ever attempted to learn JavaScript. It's a concept that, how should I put this? It can be a major point of confusion and misery and hardship and general suffering in the life of a new JavaScript developer. At least that's the perception a lot of people have. There are courage posters like this one. One of the most courageous decisions he'll ever make is to try and learn the JavaScript keyword this. Well, actually, I just made this slide myself. But the point is, a lot of people have this perception of this being this terrifying, confusing thing, when in reality, it's not that bad. What is tricky about the keyword this is that the value of it is sometimes it seems unpredictable. It seems like you expect it to do one thing and it behaves a different way. But there's a set of concrete rules that dictate what the value of this is. At this point, we haven't even talked about what this is. What's the point? So this is a keyword. Think of it as a reference to the current execution scope. It is going to give you an object back. So depending on the scope and depending on the rules of how this works, which is the confusing part, that object changes. It could be a reference to the global scope, which is what we're going to see right now. If we type a function, let's call it say hi, console.log something in here, hi, and then let's also console.log the value of this. Remember, we'll get an object here when we console.log it. This is an object, and it refers to the current execution scope. So if I run my code here, I call say hi, we get hi, and then we see an object called the window. So what is the window? The window is the global scope in the browser. We've been working with it stealthily, or it's been stealthily looming over us this whole time. When we define a function, like say hi, it looks like it's floating on its own in the middle of nowhere. We didn't put it in an object. It's not a method like we called earlier. We had math.add. That was a method, or lowercase math in our case. Say hi looks like it's just floating in the middle of nowhere. But if we look at this window object, scroll all the way down here to the S, okay, lots and lots of methods. Take a look at that, say hi. So when we define say hi like this, it is added as a property. It is a method on the window object. The window is the global scope of our browser. If I type window at any point in my console, we'll get the same thing. So this inside of a function, just a regular function, normally refers to the window, at least in the browser. In Node, it refers to something else, but there's a global object. It's not called the window, but there's a global object in Node. But remember that this can change. It's a bit of a shapeshifter, so it does depend on how it is called. So I don't want you to leave thinking that anytime you write this in a function, it refers to the window. But in this function, the way that we executed it, it does refer to the window. And just to talk more about the window for a moment here, the window contains all sorts of different properties. We've been using different methods. Things like alert. If we call alert, we get our alert in the browser. It's a built-in function, and we call it like this. But it's a property on the window, so I could also call it like this, window.alert something. And I still get the same result. Another very important thing about the window. When we declare a variable with var, I'll go with var color equals teal. That color, or that variable color, is added to the window. If I look at window again and I find color on here, there you go. It's added to the global scope. It's added to the window. So another way of referencing it, oh my gosh, I regret this decision to scroll here. Another way of referencing it is window.color. But that does not apply for let and const. We'll just do one. Let's use let. Let num equals 400. If I try and access window.num, it's not there. So let and const are not added to the global scope. They're not added to the window object in the browser, while var is. So none of that really matters at this point. We're still just talking about functions. The value of this inside of a regular old function you haven't put on an object, just a function we've defined like this one. It could also be a function expression, const How about greet equals function, and then, we don't need any arguments. We'll just console.log this. So we're not even greeting, it's a lie, but we'll just console.log this. If I clear my console over here, refresh the page, I call greet, this is still the window. So in a function, this is going to refer to the window, except when it doesn't, and that's coming up next. So just remember that this is a reference to an object, and that object represents the current execution scope. So this seems like it might not be that useful here. And yeah, it probably isn't that useful to reference the window, because we could also just explicitly write window if we wanted to print the window or do something with it. But what we'll see in the next video is where this is extremely useful when we're working with methods in an object. So if you're confused, if you're feeling like you need that courage from this slide right here, if you're feeling like this skull down here, you need a bit more courage, just hang in there. It will start to make sense as we see the other pieces. Okay, next up, we'll see where this starts to become a lot more useful. If we have an object, like a person object, where we have a first name, how about Cher? What is Cher's full name? Well, thanks to Wikipedia, I have it. Sherilyn Sarkeesian. So we'll make first name Sherilyn, we'll make last Sarkeesian, and let's also add in a nickname. Let's do nickname, camel case it, which will be Cher. All right, so we have this object. If I add a method to the object, let's do something simple like greet, or how about full name? Let's do a method called full name. We can use the shorthand that we saw a couple videos ago, or I could do it this way. I'll do the shorthand though, I think it's nicer. And inside of this method, let's console.log the keyword this to start, and now let's run it. So person dot full name, execute it. What do we get? Okay, so this time it is not console.logging the window, it's console.logging something else. Compare that to say hi, which is a function not in an object. We got the window object. The global execution context, the global scope, the window, is what this is right here. Versus here, the value of this is different. The value of this is the object itself, the person object, right here. So the value of this has been set to a different object, not the window, but the object that this method is inside of. Now, why is this useful? In the next video, we'll see that this is not always the case, and depending on how you call full name, it could reference the window, but we're going to put that aside for now. Let's talk about why this would be useful. Why do you care about the current object that you are inside of? It allows us to reference these properties or other methods. So we can have a method that is aware of the other contents in its object. So for full name, if I wanted to print out first name and last name together, I could reference this dot first. Let's start there, refresh my page. I'll call person.fullname, and we're getting Sherilyn. So this, again, is a reference to the object. Dot first will give me this value. So I could now update this to instead console.log. How about first? So this dot first space, and then afterwards this dot last. And then if I wanted to use the nickname, let's just start here, make sure it works. Refresh my page, try again. Sherilyn Sarkeesian. And then afterwards, let's do AKA this dot nickname. Try it again. Now this is a good opportunity for us to use destructuring. We're having to write this quite a bit. I could add a separate line and destructure those properties from this. First, last, nickname, I have to camel case nickname, equals this. Now I can remove this from here and here. It should still work. Let's verify. Oh, did I not save? Here we go. This needs to be uppercased. One more time. Now we get Sherilyn Sarkeesian, aka Cher. And if I change one of those values in person, let's go with nickname, person.nickname equals share with a bunch of R's in all caps. So now person has a new nickname. If I call full name again, that change is reflected. It's looking up the value of nickname on the current execution scope, which is what this refers to, and it's set to this object. So now we have the ability to write an object or a method that is aware of the object it lives in, which means we can use objects not just to store different methods because they're related, like we had add and subtract and multiply and divide. We group them together as a nice way of just making a little container for our methods that are similar. But now we have a way of also interacting with properties, with other values, or even other methods. So our object can now be a little self-contained world where we can have variables, we can have these properties. And this is a very simple example, but I'll show you some other examples as we go on. We have a little more to talk about with the keyword this in the next video, but then we're just going to see a bunch of examples of using this in methods, and you'll be able to see, hopefully, why it is a really, really nice tool to have, why you would want to do this. So let me show you one more example here with the same object. We could also add another method to the object and call a different method using this. So we have full name. Let's make a method called bio, print bio. And what I want it to do is get the full name from full name. So we'll call this method and then print something else. We'll do like Sherilyn Sarkeesian, aka Cher, is a person. That will be the bio. So I'm going to change this to return instead of console.log. So we now return that string. And then instead of print bio, I can call this.fullname. I just have to use this. If I just called full name, it would not work. We need this. If I tried it, if I call print bio, person.print bio, reference error, full name is not defined. So we have to use this to reference the object. I'm going to save that to a variable. We'll call it full name. Then I will console.log from here. Just put, let's do a template string, put full name in there, and then is a person, and that's the entire bio. So we'll try running it again, and now we get Sherilyn Sarkeesian, aka Cher, is a person. So we called a method that is located within the same object using this. In that method, we actually accessed 3 different properties, first, last, and nickname, using this, using destructuring to make it cleaner, but we're still referencing this. The value of this in both of these situations here, both methods, is referring to the object that they live in. And that's a great tool. It's a great thing to be able to reference, and you'll see a couple examples, as I mentioned, as we finish up this section. But of course, there's a bit of a twist here. In the next video, you'll see that sometimes this may not refer to the object. It could refer to something else. All right, so we've seen 2 different values for this so far. We saw that when we declare just a regular old function, we don't call it as a method. We don't put it in an object. This refers to the window object. When we use this instead of a method, it's a way of accessing the parent object, the object that the method is located in, like we used right here with this share object. But that's not always the case. The value of this depends on the invocation context of the function that it's used in. What that means is the value will change depending on how the function is actually executed, not just where you write it. So yes, I wrote this inside of a method, but that doesn't mean it's guaranteed to reference this object. It depends on how I'm calling it. And here I'm calling it how you normally would call a method. The natural way to call this would be person.printBio or person.fullname. This is what is setting the value of this, the way that I'm actually executing or invoking this function. So this is kind of a shapeshifter in this way. That's why I have these different faces down here. It's tough to come up with a good visual representation of it, but let me show you how we could actually change the value of this. What I could do is make a reference to this function, printBio. Let's work with that one. I'll call this const printBio equals person.printBio. So I'm just pointing this variable printBio to that function. It's still a property on the person object. I didn't remove it, I didn't delete it, I just made a variable pointing to it. And if I call printBio, oh, I gotta refresh the code. Try it again. We get a different error. This.fullName is not a function. So why don't we add a console.log this at the end and see what's going on. So if I call printBio again, this.fullName is not a function. Ah, well, I'm an idiot. I'm console.logging after that error. Let's do it before the error. Okay, here we go. It's referencing the window. Just like we had up here. If I call say hi, it references the window. And that's because of how I'm executing the function. If I instead execute it the way we've been doing, person dot, what do we call it, printBio, the name of this method right there, this is referring to the object. So you can think of it as if there is something to the left and then a dot, and then you're executing the function, this will be set to that thing to the left. If there's nothing to the left, if we're just calling say hi, or if we're just calling printBio, this will be set to the global execution scope, the window. So this is the confusing part of this. It's not set in stone. You probably won't call your method this way. It's not something you would do all the time, but it's important to understand how it behaves. There is a very significant difference. So generally, when you write this in a method, you're going to call it using the dot syntax. You're going to call object.methodName, person.printBio. Everything will be great. Everyone's happy. This refers to the object itself, the parent object that contains the method. But that doesn't mean it always is set to that value. It depends on the invocation context, how you actually execute that function, the line that you write that runs the code, or that runs the function. Later on in the course, we'll see that there are some additional rules and some ways of changing the value of this. There are 3 special methods that are usually grouped together: call, apply, and bind. Those will come up later. We'll talk about classes and prototypes and creating new objects. That all has to do with the keyword this as well. So right now, this is just a quick introduction. I want you to be aware of how this works in 2 of the most common scenarios. And then there's one more thing to talk about, which is arrow functions. When we write an arrow function, this is one of the key differences between a regular function and an arrow function. Arrow functions do not get their own version of this. It doesn't matter how you call an arrow function. If you execute it as a method, where you call object.name of the function, or if you just call the function directly, the value of this is not going to be changed. So in that way, they are very different from a traditional function, and I'll show this very quickly. Let's just make a function called, this is the hardest part of teaching anything. Coming up with examples, we have full name, printBio, how about laugh? Okay, so we'll define our function, which will be an arrow function, as a method. I'll use this key syntax, key value, put the colon in there, and inside of this, I'm going to console.log this. And for laugh, let's console.log this dot, let's do a template literal. Let's put this dot nickname says ha 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 ha. Okay, so we have this laugh method. If I try and call laugh, person dot laugh. Okay, first of all, the value of this is set to the window, which is very different than the value of this in printBio or in full name. As we saw when we call printBio, this is set to the object, the person object. An arrow function does not behave that way. The value of this does not change in the arrow function. It's a reference to the global scope, to the window. So sometimes that can be a good thing, but generally, this is why we don't use arrow functions as methods, because a lot of the methods we write, we want to have access to the parent object or the containing object to do things like reference properties or call a different method like we did inside of printBio. We called this.fullName. In an arrow function, we couldn't do that, at least not until we see things like bind. So for that reason, we usually don't use arrow functions as methods. in an object. But there's a reason that arrow functions don't get their own this. If you only use regular, standard, traditional functions like this, so annoying, like this one right here, there, hopefully that's clearer, like this one right here, sometimes you can run into issues. And I'll show you an example of where that can happen in the very next video. So to summarize what we saw here, the value of this is set by the invocation context. It's not set in stone purely based off of where you write it. In this case, we put it in an object instead of a function inside of an object. We reference this, and when we called it as a method, person.printBio, this was set to the entire object, the parent object, versus when we made a reference to that same function and instead called it just as a regular function without something to the left, without object dot something, just printBio, this was referring to the window. So the execution context matters. The way that you actually invoke it does matter. And then the second thing we saw was that arrow functions don't get their own this. And in the next video, I'll expand on how that sometimes can be useful. Next up, I'd like to expand upon arrow functions and this. Why do arrow functions not get their own this? And how can it be useful sometimes? So we're going to make a little example. I'm calling it the annoyomatic or the annoyer, annoyatron. It's going to have a list of annoying phrases. These drive me insane. Literally, cray cray, I can't even, totes, YOLO, and can't stop, won't stop. They don't drive me insane. That's a bit over the top. But I'm not a fan of these phrases. So we're going to make this little annoyer that every second, every 2 seconds, every 500 milliseconds prints one of these random phrases to the console, and we just fill up the entire console with a bunch of annoying phrases. And the way we're going to structure it is by using an object. So I'm going to make an object here. I'll call it annoyer. And I'm going to add this array, and you can put whatever array you want in there. If you like some of these phrases, I am very sorry if I'm offending you here. Please pick your own phrases. I'm sure you can find a good number of annoying phrases to draw upon just from my own courses. I say, at the end of the day, pretty much every video, no matter what time of day it is, or essentially, basically, oh gosh, I can't listen to my own videos. Okay, so I'm going to add phrases as a key here into my object. And then I'm going to add a method. The idea is that I'll have a method called start and another one called stop. And I want to be able to call annoyer.start, and that will start printing one of these every second. And I can call annoyer.stop to stop it. So to do this, we'll take advantage of a built-in function called setInterval. SetInterval is a global, it's located on the window. If we look at the window, it comes in your browser for free. If we scroll way down, all the way down to S, where are you? SetInterval, right there. So it's a function, we call it, and we have to pass in a couple things. SetInterval, we need to give it a func to run and a time, or the interval. So for us, we'll start with something easy, like 3,000 milliseconds. So whatever function I put here will run every 3 seconds. So I'm going to delete that and instead add a method called start. So after my phrases, I'll add a method called start. I need a comma here, which will be a function. And then actually, I'll use a shorthand, get rid of the function keyword. That's nicer. I'm also going to add a method called pick or choose phrase or something so that we can easily get one of these. So I'll define that first. How about just pick phrase? And in here, I'm going to reference this dot phrases, which we've seen that works as long as I'm calling this as annoyer.pickPhrase or something.pickPhrase. I just don't want to be calling it as a non-method. So this dot phrases will be the phrases, it's the entire array. To pick one randomly, what I need to do is get the length of this array. I'm going to need to do a math.random, multiply that by this dot phrases dot length, and I'll probably make this its own variable, const phrases equals this dot phrases, or destructure it, const phrases equals this. So math.random times phrases.length, and then I need to floor that, so math dot floor, and then I'll call this const index. So that gives me a random index from this array. If we add two phrases, this will reflect to update that when I call phrases or pick phrase. This dot phrases will reference the current version of phrases. Okay, so that gives me that, but then I need to access it out of phrases using that index, and I'll return that. So I used destructuring here just so I didn't have to reference this dot phrases dot length and this dot phrases of index. Maybe it's overkill, but we also just learned destructuring, so it's always good to get some reinforcement there. If I run this code right now, oh my gosh, I'm going to clear my console. If it will stop lagging, the window object made it very unhappy. All right, it should be back to normal. Refresh my code, annoyer dot pick phrase. We got YOLO, and then cray cray, I can't even, YOLO, literally, I can't even, totes. Okay, so we're getting a random element each time. Can't stop, won't stop. Great, I will stop. What we're going to do now is call pick phrases inside of start using setInterval. So remember, setInterval takes two arguments, the thing that we want it to call. So I'll just write an anonymous function here. And I'll start by just console.logging some random letters. And then the second argument is how often I want it to repeat. We'll do 3,000 milliseconds. So right now we're not using pick phrase. I'm just console.logging some gibberish. And if I execute annoyer.start, wait 3 seconds. Come on, there we go. We got our first one, 3 more seconds. We get our second one, 3 more seconds, we get the third one. But what I want to do is console.log pick phrase. Now this is where the keyword this comes in, because we know instead of a method, start, I can use this to refer to the object. So I could call this.pickPhrase. So if we just tried it once up top here, in the method console.log this.pickPhrase, and I run this, annoyer.start, we get literally. And that works. And then the set interval kicks in. But if I want to call this code, this function, instead of console.logging, I will do the exact same thing, console.log this.pickPhrase, but if I move it in this function, everything changes. The first one works because it's up top, but then we get an error. This.pickPhrase is not a function. So why is this different? We're inside of this function. Why is it not working? Well, let's look at this. What do you think the value of this is right here? One more time, annoyer.start, cray cray, that's coming from line 11. And then this is set to the window. So why is this right here set to the object, but inside another function, it's set to the window? Remember, this changes depending on how it's called. Now we're executing start ourselves as an object or as a method. We're doing this annoyer.start. But this function is being executed not by us, but by setInterval. Its source code calls this function every 3 seconds or whatever number we have here. So we're not calling it. And that means that this, because of the way it's called, is set to be the window object. Just like if we had a random function and we called this, we've done this a couple times in the past few videos, if we don't execute it as a method on an object, this is set to the global scope, to the window. So all of this has been set up to talk about arrow functions. In the past, before arrow functions were a thing, if we wanted to make this work, if I want to have a reference to the object, the version of this we have right here, I want to be able to call this.pickPhrase in this function, the nested function, what some people would do is make a variable and store it. You'd see things like const that equals this. So we have a reference to this, which is the object. And if I console.log that, and I call annoyer.start, we'll still get an error because we're doing this.pickPhrase, but that is a reference to the previous this from the level above, from the start function. So this is not ideal, writing it this way. Also, they wouldn't have used const because it wasn't a thing. You would have seen var. Still, not a great approach. Once we talk about bind call and apply. There are other ways of getting this to work, but now that we have arrow functions, it's actually easier. If we instead use an arrow function here, we avoid the problem entirely. Remember that arrow functions don't get their own this. The this in an arrow function won't change from the this of its parent, or of its nearest this, the local execution context that we have up here. This has a value. We've already seen it. If I type this right here, it's referencing the object. Because I'm not using an arrow function, I'm getting a new this. But if I turn this into an arrow function instead, like that, now we have no problem. It shouldn't be an issue. This is going to be the same in this arrow function because arrow functions don't get their own special this. That means it just relies on the this we have from start. Let's make sure. We'll run it. And come on. I can't even. And 3 seconds later, can't stop, won't stop. Oh, so annoying. Who built this thing? Cray cray. And literally, it's working. So that's really what I want to focus on in this video, is showing you that sometimes arrow functions are better to use because you don't want a new this. But the other side of that coin is that they suck as regular methods on an object because you don't get access to the this referencing the object. Your this references the window. So that's nice in a situation like we have here because we will use the this from start, but it's not nice if I had tried to write start as an arrow function instead of a regular function expression. Now, one other thing, this is not related to this. This interval is going on and on and on. It will keep going until I refresh the page or close the window. It's best practice to provide a way to stop that interval, to stop something from repeating over and over, not to mention the fact that it's incredibly annoying, whoever built this evil piece of code. What we can do is save the return value from setInterval. SetInterval will return a ID. And there's another function we can call called stopInterval, or no, clearInterval, which will stop the interval from running. So how could I do this? If I wanted to have a stop method, I want to call clearInterval, but I need to pass in an ID. But I'm getting the ID from here. This is going to return it. If I just make a variable like const ID equals setInterval, I have no access to ID over here. What I can do is add it to this. This dot timer ID, let's call it that, equals setInterval. Let's take a look at what happens now if we inspect Annoyer. Open this up. Well, I haven't executed, I haven't called start, so I need to run that. But now if we look at Annoyer, we do have a timer ID. That wasn't there before, but the code ran, start was executed. This is set to the object. So this .timerID added a new property called timerID, just like we had done this, except the ID is not hard-coded as 1. If we have multiple timers, we have different IDs. So to stop it, my method called stop would just call clearInterval this.timerID. So setInterval, clearInterval, that's not really the focus of this video if you're struggling with the syntax. It's more about this and arrow functions and context and all that fun stuff. Let's add a quick console.log at the end. Phew, thank heavens, that is over. Okay, so I'm going to run my code. I'll do annoyer.start. And eventually I will stop it. I won't run it yet. We'll get a few of them. One more. Okay, one more other than cray cray. And it stops iterating, or it stops intervaling. I don't think that's the right terminology, but it's not printing out those annoying phrases anymore. All right, so kind of an obscure demo, but hopefully this illustrates that sometimes arrow functions are great to use because of the very fact that they don't get their own this. So what seems like potentially a shortcoming, and what is a shortcoming when it comes to defining methods, is an advantage when you have to deal with nested functions and callbacks and different execution contexts where this gets really annoying. Use an arrow function and you don't have to worry about it because this will be identical to the this of the parent function of start in our case. Oof, this is just a joy to teach. Hopefully you're still there, you're still alive, you're surviving, and you're with me. Next, we're going to see some examples of using this in methods, and we'll talk more about why you would even bother creating methods, why organize our functions like this. We could have just written a function called start and stop. We could have had a global variable called phrases. So we'll talk about that in the next video. In this video, I won't be covering any new syntax or features that we haven't seen. I just want to give us some practice and a little bit of time to talk about objects, methods, designing our code, why we might want to use objects with methods, and comparing that to different approaches that we've already seen. So early in the course, when we were talking about functions, we had a functions exercise where I asked you to make a function called, it was something like makeDeck, and I wanted it to return a deck of cards, which was an array, and each element had a value, like value of 5, and then a suit of hearts or diamonds or something, so 5 of hearts. But the deck would have 52 of these, each different, right? We'd have 5 of hearts, 5 of diamonds, 5 of clubs and spades, and then 6 and 7 and jack, all those different cards. So that's the idea. And we can totally use a function to do that, just a standalone function. But what if I wanted to also have different features, different functionality for my deck? Instead of just making a deck of cards, what if I wanted to be able to draw a single card at a time? Or maybe I want to have a discard pile. Once we draw a card, we could put it in the discard pile. So our deck would be shrinking, but then we would have the discard pile that was keeping all of the previously drawn cards. Or I could implement a shuffle so that we could shuffle the deck. Or what if I wanted to refill the deck, start over from scratch? There's so many different things we could do. We could make a draw method that could take an argument like draw 5, draw 2, draw 1. And to design that, to actually implement it, we could start with a pure function approach. So I could have my makeDeck function, which I need to actually call a function. And then I would loop over these 2 variables that I've created already to save some time here. I have suits, which is an array, and values, which I made a string instead of an array, only to save a little bit of time, because typing this as an array is really annoying, having to do 1 and then 2 and put quotes around everything. And I did separate them by commas because that allows me, if I come over here, to do values.split on the comma and get an array with the actual values. The reason I had to do commas, instead of just doing 1, 2, 3, 4, 5, 6, 7, 8, 9, Jack, Queen, King, is this little guy right here, 10. If I were to iterate over this string, I would get each character one at a time, and that works. All of these values are a single character long, except for 10. So if I were to split, if I had 10 in here, or if I were to iterate over this, it would do 1 and 0. I wouldn't actually get 10. So that's why I used a string with commas. But I'm going to start by looping over suits. My goal is to return an object that has a suit set to one of these suits and a value set to one of these suits, and make them all unique. So we have a combination of every possible, we have an instance of every possible combination. So for let value of, and then I'm going to do values.split on the comma. So that gives me this array here. So for every item in that array, we'll also loop over suits. For let suit of suits, and then I'm going to create a deck array up here. Const deck will start empty, and then in here I will call deck.push, and I'll push on a new object where we have value set to value and suit set to suit, coming from these loops. But as we just saw very recently, we have a shorthand way of doing this. If we want the key name to be value and we have a variable called value, I can just put value and suit. All right, so let's return this deck. Return deck, run my code, make deck. Oh, forgot my parens. And we're getting 56. What did I mess up here? Well, that was stupid. I put ace and 1. There is no 1 card. So let's run it one more time. Hopefully you saw that before me. Now we have 52 cards. Okay, so we have this function, still no objects or methods involved. I guess we do have this object that we're creating, but no methods, no this, none of the stuff we've been talking about. If I wanted to create a deck and then be able to draw a single card, I would need to save this deck to a variable. So make a new deck. We'll go with const my deck equals make deck. And then I need to make a new function called drawCard. And I would need to pass in the card, or excuse me, pass in the deck as an argument. And then we draw the card. So we could do, let's pop from the end, I guess, or we could take from the beginning. Either one works, but let's just pop one off. So deck.pop. And if we try it over here, make deck.pop, remember that pop returns the value, and it also changes the original array. So I can simply return deck.pop. Okay, so in order to draw a single card, I make the deck, and then I need to call draw card and pass in my deck because we need an argument here. So then I would save that return result to const card1 equals draw card. And if I run it, I take a look at card 1. We got the ace of clubs. We haven't shuffled our cards at all, so they're all in order. And then if we look at my deck, it should now be 51 items. So then to draw a card again, I have to do draw card, pass in my deck, and this is not great to have to keep passing this around. I'm passing my deck into draw card over and over and over. And if I were to have a shuffle function or a refill deck or draw 5, I would need to keep passing my deck. I guess the alternative would be to use global variables and make a variable up top called myDeck, const myDeck equals makeDeck, and then inside of all of the functions we write, we could refer to myDeck specifically, but that's even worse because then we end up with just one deck. I could do this, const mainDeck equals makeDeck, and then I would down here rewrite drawCard to just return mainDeck.pop. But you can imagine that this is severely limited. We can only have one deck, main deck. How would I make deck 2 or second deck or fifth deck? I would have to write a new function that didn't depend on it. I'd write a new one where I hard-coded in second deck. So that's not a good approach. So the best option for now is to keep passing them around, pass the deck in, so that we can make draw card somewhat modular. Now this is where objects come in, because I can use an object to store the deck, and on that object I can have a method called drawCard, and another one called shuffle. And we have access to the deck because of this, the keyword this. So here is how I would rewrite that. I would do something like const deck, or my deck, or whatever, equals an object. And then I would have the property, instead of calling this deck, let's go with my deck, and then make our property deck, which can start as an empty array. Then we'll have a new method that we'll add in called makeDeck or refill cards or something. What should we call it? Initialize cards, initialize deck? Sure. And it is going to update the deck property. So we're grouping the data with functionality. So let's just copy most of this logic over. Just move this over. And it's not going to work right away. We need to change a couple things. The first thing I might do is move these variables into properties on the object because we might want them in other methods. We don't need to redeclare them every time we call initialize deck. So I'm going to just copy this out or cut it out, make a property called suits, and then another one called values, and move that. We'll get rid of that right there. And then we can import them. We're not actually importing, but we can use them in here because of this. So this dot suits, this dot values. We could also just use destructuring. So const suits, comma values equals this. And let's also grab deck. So now every time I reference deck, it's actually this dot deck. Values is this dot values. I've just destructured them. What do I have going on here? I'm missing a comma. There we go. Okay, so I have those values now. So for let value of values.split, that's right, we get an array. For each value, we're also going to iterate over all the suits, all 4, and now I can leave this as deck.push, instead of having to do this .deck because we destructured it up here. Where are you? Right there. And then we can return the deck if we want, but also we don't have to. We're not going to lose that deck. Versus here, we had to return the deck and save it to a variable. Otherwise, we're just making this array, and then it disappears when the function's over. But in our object, we're actually changing the property of deck. We're adding to this array. So even if I don't return deck, it still should work, assuming I didn't mess something up when I copied it over. Let's see what happens now. I have this myDeck, which is an object. It starts with an empty array. But if I call myDeck.InitializeDeck, kind of a long name, let's look at myDeck now. Or how about just myDeck.deck? We have 52 cards. So we successfully implemented this method that is updating the deck property. And now if I wanted to implement a draw method, it's very easy. I'll just add my comma in, draw card, and why don't we make this a little bit more exciting? Well, we'll start with draw a single card. So draw card, and we'll access this dot deck, and then we'll pop one off, and we'll return that so that we have access to the card that was just drawn, but now we also are updating this dot deck. So I don't have to pass anything around if I want to use it. I just do myDeck dot, and let's initialize the deck. And then we'll also do myDeck dot, and then draw a single card. We can save this to a variable, const card. Oops, I didn't add my parens, and I'm going to get an error if I use const again because I already declared card. Oh, geez, I'm an idiot. We can't update const. All right, well, let's go with a different name. Const card1 equals myDeck dot draw card. And we look at card 1, we have that card that we drew. And if we look at the deck itself, myDeck dot deck, where are you? We now have 51 cards. So notice, we didn't have to pass an argument around. We didn't have to do what we did here, where every time I want to draw a card, I have to pass in the deck we're drawing it from. Instead, we group the method with the values. We put the data and the functionality in a single object. So now all we have to do is access this .deck, and we're updating this one object. This whole thing represents a deck of cards. And we have different things we can do with the data. We can initialize it again. We can draw a card. And let's actually add a new method that will draw multiple cards. And before we do that, let's add a discard pile or a drawn card pile where we can keep track of the cards that have already been drawn. So instead of just returning this .deck.pop, we will pop an element off, we'll pop a card off, but before we return it, we'll also make sure to add it to the drawn cards. So drawn cards can start as an empty array. And then here, when we draw a new card, we'll do this .deck.pop, but we'll push that on to the drawn cards array. So we could just put this in a variable called card equals this .deck.pop, and then we can do this dot drawn cards dot push card, and then return card. So now if we run it, myDeck.InitializeDeck, myDeck.draw the first card, we'll draw a couple. Now let's look at myDeck. We have drawn cards right here, and it has 6 elements, 6 cards that we've drawn. And now if I want to make a method to draw multiple cards, we could just make draw cards or draw multiple, which will be a method. We'll pass in a number of cards, num cards, make sure to add my comma here, and then I would just loop num cards times and take advantage of our draw card method we already have. So let's do a regular for loop, for let I equals 0, I less than num cards, I plus plus, and then we want to call this dot draw card, this method here. This draws a single card, it adds it to the drawn cards array, and it returns that card. So we'll call that multiple times, but we want to return all of the cards that we're drawing. So if somebody says draw 8 cards, draw a multiple of 8, we want to have an array, we'll just call this const cards, that we return. So we'll draw the card and push that onto cards. Cards.push the card that we get back from draw single card, draw card. And then at the end, we will return cards. Let's see if that one works. So we have my deck dot initialize deck, and then my deck dot draw multiple of 4. We get back an array with 4 cards. Let's look at my deck. Does it in fact have a smaller deck? Yes, it does. We're down to 48, and drawn cards has 4 elements. Cool. Next, we'll add a shuffle method. Now, I've gone ahead and written a simple shuffle method. Shuffling things is actually not as straightforward as you might think. There's a ton of ways of doing it, and sometimes you run into issues with randomness and random numbers not being as random as they should be. So this is not by any means the best shuffle that there ever is, but I'm going to walk through how it works in like 30 seconds. This is an algorithm called the Fisher-Yates shuffle. It's used to shuffle an array. And I'm going to console.log in this loop the array that we pass in so you can see how it works. I'm going to call shuffle on this array of strings, and we can see what happens each step of the way. So we loop over the array backwards. We start at the end of the array, so the original array looks like this. So we're starting with F. And then we pick a random index before F, so any of these, and we swap the two. So the choice that was made the first time through was B, so we swapped F and B. And then the loop moves on to this letter, E, or this index, and we swap it with something before it. We pick a random index between 0 and whatever this index is, and we swap. So we swapped with C that time, so then we move on to this index. And so we're shuffling it from the back, moving towards the front. We swap with some random index before, and then we move on. We swap with something before, move on, and we end up with this. And if I call it again, we'll likely get something different, as you can see there. So not the focus so much of this video, but here is a simple implementation. If you want, definitely look into more complex implementations. It's kind of fun, different ways of shuffling, but I'll just add some quick notes. Loop over array backwards, and then here pick random index before current element, and then swap. Now this right here is a nice shorthand way of swapping elements using destructuring. Don't want to get too sidetracked here, but I'll show it to you briefly. If we have this array from earlier, we'll call it letters. If I run this line, let's do letters of 0, comma, letters of, how about 3? So that should be A and D equals, and then do the inverse. Letters of 3, comma, letters of 0. What this will do is swap our elements in place. And if we look at letters now, D is now where A used to be, and A is now where D used to be. The shuffle is not really the focus of the video, but in order to make our deck slightly more useful, we should add shuffle. So let's go ahead and do it. We'll add in our method shuffle, which I need to change a couple different ways. First, I need to make it a valid method on our object. I'm not going to pass in an array. It should just shuffle the deck, right? It shouldn't shuffle an array we pass in. So anytime I have that reference to ARR, I'm going to replace it with deck. So I'm going to destructure deck, this. I don't know why I'm writing this backwards. Const deck equals this. So that is destructuring the deck out of this. And then we're going to replace array, that time, there, with deck. So now we have a shuffle method. This.deck, we don't have to pass anything in. Let's make sure it works. So my deck.initialize deck. And as we've already seen, the way we built the initialize is that it just puts them all in order. So we have, 2 of hearts, and then 3 of hearts, and then 4 of hearts. Or did I do it backwards? I think we have 2 of hearts, 2 of diamonds, 2 of spades. But let's just look. So we do mydeck.deck. Open this up. And yeah, we have all the 2s, all the 3s, the 4s. So let's shuffle. My deck dot shuffle, fingers crossed, didn't mess anything up. Let's look at my deck and open up deck. There we go. Totally shuffled. Awesome. So hopefully you can see from this example that putting our code in an object is not something we always need to do. It's not the end all be all. There's lots of these different patterns out there for organizing your code or for structuring, designing your code. This is just one option where we put things in an object. And this is still a very, very simple version. There are other patterns we'll talk about once we get to prototypes, once we talk about creating constructor functions and working with JavaScript classes, which is all coming later on. But this is still nice, right? We don't have to pass anything around. I'll fast forward through this so you don't have to watch, but I will re-implement all of this outside of an object and show you how we would achieve the exact same thing, and we can compare how ugly the code is or isn't. All right, so I took our object from down here that we created, my deck, and I rewrote it as just standalone functions. So we have our initialized deck. This used to be called make deck, but I renamed it just to match what we have in our object. Initialized deck creates the deck of cards in order. Then I have draw card, and we need to pass in the deck. And if we want to keep track of the drawn cards, the cards that have already been drawn from the deck, we need to pass in a second array called drawn cards. If I want to draw multiple, I need to pass in the number of cards to draw, the deck to draw from, and the array to put the drawn cards in, that pile of cards that have already been drawn. For shuffle, I need to pass in the deck. So here's what it looks like when I start using it. I'll have things like draw multiple, pass in the number of cards to draw, the deck, the array that I'm drawing from, and the drawn cards array that I've made, an empty array called drawn cards. So every time I want to draw a card, I'm going to have to pass in all of these arguments. If I want to get a new hand, let's call it const poker hand equals, well, I guess most poker hands are 5 cards. Let's go with blackjack. I was going to say, I was going to write BJ hand, but that might not be, I guess we'll go with poker hand equals draw multiple. I guess we can draw 2 for each of these, and then our poker hand will draw 5. We need to pass in the deck that I made up here and the drawn cards array. So this gets pretty tiresome. Not to mention, if I want another deck, it's really annoying because I'm going to have to keep making these variables and I'm going to have to keep track of them and pass in the correct drawn cards. If I have 2 different decks, I'll have one drawn cards array for one deck and a second one. We haven't seen how we can use our object and use it to make multiple decks from it. So we'll get to that in the next video, but for now, here we go. This is one approach. No objects except for the actual cards themselves, which are an object with a value in a suit. Everything else is functions for passing things around. It gets kind of annoying, but let's take a look, make sure it all works. We've got our deck. It has 43 cards left because we drew 9 of them. If we look at hand 1, it has 2 cards. Also, the deck should be shuffled because I called shuffle. If we look at poker hand, it has 5 cards. And if we look at drawn cards, it should have 9 cards. So that's all great. Now down to our object version. To do the exact same thing, let me just see what we did. We drew 2, 2, and then 5. To replicate that, we would call my deck dot initialize deck, my deck dot shuffle, my deck dot draw multiple, and we'll do 2, and we can save that to a variable. Const, we'll call it h1 for hand 1, h2 to draw 2, and then h3 will draw 5. And that's it. We don't have to keep passing a bunch of arguments in afterwards like we did here. It's a lot easier because all of the relevant information, all the values are stored together in my deck. I don't have to manage the drawn cards versus the deck array. I have it together. It's all here. Versus, in this example, I have to keep track of drawn cards myself, pass it around. It's just not ideal. So I recognize this has been extremely long and probably not the most enthralling video I've ever made, but it gets at some very important stuff. that using objects is a great way of organizing your code, of grouping content together, or a better way of saying it is grouping values with functionality, things with actions. And we've grouped them together in a logical way where we can start writing our methods, our functions, in a clean syntax where I don't have to pass a bunch of stuff in. I don't have to save everything to a new variable because everything is done on the object itself. The object stores those values, and then these methods act upon those values thanks to our good friend, this. Next up, we'll see how we can create multiple decks. Right now, I'm stuck with one deck. That is probably the big disadvantage to what we saw up here. Here, I could make another deck at any point by just calling initialize deck. I still have to write a bunch of code to get the deck, make a new drawn cards, shuffle the second deck, but I can do it. Here, we have one object. So how do I make another one of these? That's what we'll see next. Okay, so if you're still with me, we made our deck of cards object called myDeck. It's a single object, and right now, I don't have a way of making another one. So I'm just going to show you a quick and dirty approach to creating multiple decks. This approach I'm going to show you is not the end-all be-all. This is not the best way of doing it, but we haven't covered things that we would need in order to structure this in a nicer way. We haven't covered constructors. We haven't talked about the new keyword. We haven't talked about classes. There's a lot of stuff we have to get to where we could refactor this nicer? We could refactor this in a better way. But what I'm going to show you here is a very basic approach where we could just make a function that makes one of these decks for us. It's long, but I could just copy this, define a function down here. I'll do an arrow function for the sake of variety. Let's go with make deck. And make deck is going to return this whole object. So our entire deck, this thing I copied except for the variable name and the equal sign, I copied from curly brace to curly brace. So now we have this function called makeDeck, and I could just delete this entirely. We're returning this whole object, and we could even do this implicitly if we wanted to. Just put parens, get rid of the return keyword. So to use it, instead of calling myDeck.initializeDeck, I now need to say const myDeck equals makeDeck. And this returns to me a new deck. Let's make sure it works. myDeck. There we go. So we have this deck. I drew how many cards from this? 9 cards. If we want a second deck, we'll go with const deck2 equals makeDeck. Do it again. Let's look at deck 2. And then let's also initialize it. So deck2 dot initialize deck and deck2 dot, let's not shuffle this one, just so we can see the difference. So we have deck 2 now. It has 52 cards, no drawn cards. It's all looking good. And then if we look at my deck, it has 43 cards and they are all shuffled, as you can see here. And we have 9 cards that we've drawn. So we have totally separate decks. They are separate objects because we made a function to return an object. So we're returning a new deck each time, a new object with these methods: draw card, draw multiple, shuffle, initialize deck, a separate deck array, a separate drawn cards array, and we return that every time we call makeDeck. So now we have a way of creating multiple. But just to reiterate, this is not the best way of doing it. It's the best way of doing it with what we know right now. And it's certainly better than doing it with all those functions and all the stuff we saw in the last video. This is still pretty clean. It's not too bad. And I'm going to stop here. So we're going to move on to DOM manipulation for a bit, take a break from all this object stuff and working with this. We'll see how to work with HTML and CSS through JavaScript, how we can add events to our page, lots of fun stuff. And then we'll come back to objects because it's a big topic. We'll talk about classes and constructors, and we'll see different ways of structuring this code. Alrighty.